Hi folks, this week I'm releasing this extra video because many of my students are going back to school this week, and I want to give you guys some strategies so that you can make the most out of the year, particularly in your math classes. I know it's going to be a bit of adjustment this year in particular. So nothing really groundbreaking here, but normally I tell my students that there are three things that really make for a great math student. Number one is learning and memorizing formulas and concepts. Number two is training yourself to spot patterns. And number three is practice, practice, practice. These three activities are interrelated, and I want to give you some specific tips on how you can make the most out of each one. Okay, let's talk about learning and memorizing formulas and concepts. I have an atrocious memory, and I used to forget my students' names all the time. So these suggestions are things that I've picked up through the years that really have improved my ability to retain information. First, deriving and building off of existing formulas. There are some students I have who they really can't learn a formula unless they know where it comes from, or if they see it comes from a specific formula they learned earlier in the year. Many students find acronyms and shorthands to be very helpful for learning formulas. I'm a very visual learner. A lot of my students are, so having visual aids and auditory aids. And then the last one I think is a huge one. It really will take you up to the next level as a student, grouping and organizing ideas that you learn through the years. So I'm going to run through some examples of what I mean of these four kind of tips for improving retention. So right here we have the distance formula, which is a formula that I find that many of my students just have a hard time recalling. But once I show them that it actually springs from something they're very comfortable with, they seem to have an easier time of retaining it. So for example, if we look at this right triangle over here, we can see that I've illustrated above the Pythagorean theorem, and we could give these points, these vertices on the triangle, some coordinates. We could pretend this was in a coordinate plane and say this would be x1, y1, for example, and this would be x2, y2, and down here we would have the point x2, y1, because it would be horizontal with that first point and directly below that second point. We know that A is this distance on the triangle right here, this horizontal distance, and we could express that as now x2 minus x1, and we have that in our formula right here. That is length A. So distance formula is just taking one side of the triangle squared, and B we could now represent as y2 minus y1, and that appears right here in the distance formula. So once we see that, and if we take our Pythagorean theorem and we solve it for C, we get C equals the square root of a squared plus b squared. Now we kind of get, hey, the distance formula is nothing more than this formula, except we're making specific what a and b are using coordinates. Down below, we have a trig identity, which is actually known as the Pythagorean theorem in trig. I'm not going to derive this one, but it is another useful formula to memorize, particularly for a pre-calc class. And once you realize, hey, this is just Pythagorean again, particularly because 1 squared would just be 1, then it's a lot easier to retain that formula. Another quick note about memorizing formulas. Yeah, it's a lot more convenient to memorize c squared equals a squared plus b squared than it is to memorize the hypotenuse squared of a right triangle is equal to the sum of the squares of its legs. But you're going to be doing yourself a disservice if you just retain the letters, because sooner or later a teacher or a standardized test are going to switch up those letters on you. For example, here we have a as the hypotenuse. So our formula that we're really familiar with is not going to be correct in this instance. We're going to want to say that a squared equals b squared plus c squared. So do yourself a favor. Don't just understand formulas as a bunch of letters. Understand that's a shorthand, and really memorize the concept if you can. So again, deriving a formula is a great way to help you memorize it. Here we have the circle formula, pi r squared. And on the right here we have the volume for a cylinder. And if we can see that pi r squared is in there and understand why it's in there. So for example, if you look at this cylinder, you could treat it like it's a bunch of circles that are just stacked upon each other over and over again. And if you retain that, then you're going to realize, okay, well, I know that the formula for the area of a circle is pi r squared, and I just need to figure out how many of these circles am I piling on top of each other. That would be the height. And so that's why we have h in the volume formula. So just understanding that will help you remember pi r squared h is the volume for a cylinder. So in addition to deriving formulas, using acronyms and shorthands is also a very good technique for helping to memorize them. Teachers will often use these, but I'm surprised sometimes when I have students and they'll know what, like, for example, foiling is, but they won't actually understand what the letters stand for and how it's actually supposed to help with multiplying out a couple of binomials like this. So, for example, f stands for the first term in each of the equation. So when we do the f part of foiling, we are going to get an x squared in this case. O stands for the two outside terms, the terms that are in each binomial farthest away. So in the first one, all the way to the left, and in the second term, all the way to the right. So the outside terms here will produce a b and an x. I stands for inside, so the two inside terms. In this case, that's going to be a and x, the ones that are closest together, so that's going to give us an ax. And then finally, L stands for the two last terms, so a and b, and that will give us a final term of a times b. So great, learn these acronyms and shorthands, but make sure you understand what they mean. And a second real quick example, most of us know this, SOHCAHTOA. We know it's supposed to help us with trigonometry, but particularly in this last year, I know a lot of students have been introduced to it, but don't necessarily know it's helping you set up the trig ratio. So for example, let's talk about SO, what that actually means. Don't just memorize SO and think you're done. Understand, this is telling me that if I take the sine of an angle, it's going to produce the relationship that is the opposite side from that angle over the hypotenuse. And then COT and TOA will help tell you for cosine and tangent respectively. We got a whole bunch of other acronyms we learned, PERT, SOP, all throughout high school. They're great. I use them. I think it's a great technique. But make sure you understand what the acronym stands for, because otherwise it's really not going to help you. All right, so the third kind of tip I would give you for learning and memorizing formulas is one, use visual aids if you're a visual learner. This is me, definitely. I benefit greatly from visual aids. So I have students who frequently cannot recall the difference between the area formula for a circle and the circumference formula. They mix them up, and having sort of a diagram or picture in your mind of which one is which will really help. So in case of our circle, it's pi d, or I'm going to write 2 pi r. And the area is pi r squared. All right, now you can do pi d, but I like doing 2 pi r because this kind of goes in with the next technique of grouping and organizing formulas. They have the same basic components, a 2, a pi, and an r, but which one's which? Which one's squared? Which one has the 2 in front? Now, if we visually think of a circle, the circumference, right, is the length outside the circle. We could take that length, we could cut it open, stretch it flat, and we get a straight line. That's a one-dimensional shape. That should help us recall that 2 pi r, which is one-dimensional, is our circumference formula. The area of a circle is two-dimensional. It's going to be this space inside of the circle. So it makes more sense that that formula is going to have a squared term to give it 2 dimensions. So having that visual along with those formulas is a great way to help remember, in this case, which formula is circumference and which is area. Now, some people aren't visual learners. Some people are more auditory. They like to hear things out. They like to create little songs to help remember formulas, maybe have little sayings. Here's one that we frequently see in pre-calc. All students take calculus. And what this saying is supposed to help us recall is which trig functions are positive in which quadrant. So, for example, all supposed to stand for the fact that all the basic trig functions, sine, cosine, tangent, and the reciprocal functions are positive in the first quadrant. S just sine, T is just for tangent, and C is for calculus. We had a different term that we used in high school for the C, but whatever works for you is fine. I personally don't like to use this acronym. I find for me it's more trouble than it's worth. So I use a visual technique here. I understand that cosine is linked with my x values. So wherever x would be positive, which would be to the right of the y-axis, all values here are going to have positive values for x. So I know all the cosines are going to be positive there. Similarly, y is linked to sine. So all values above the y-axis, or the x-axis, I should say, are going to have y values that are positive, and therefore sine values would be positive there. That also helps me remember tangent, because tangent is a mix of sine and cosine, and I can very quickly, with that visual, figure out which trig function should be positive and which one should be negative in a particular quadrant. But do what works for you. If you're more visual, maybe my example will help. If you're more auditory, then all students take calculus. That might be the way to go. Okay, final tip for learning and memorizing is grouping sort of like concepts and organizing material from the class year. This was huge for me. This is what really turned me around and made me a great student. Just because a book or a teacher presents material in a certain way, that might not be best for you. And for those of you out there who really like the Container Store, you like organizing things, this is a technique for you. I find that I retain information better when I give it its own structure. So for example, here I have maybe a page I would start making for a geometry class where I'm storing all the information for triangles. I know in the beginning of the year you guys tend to cover angles and triangles and the naming of triangles. And then you might skip and start doing parallel lines with a transversal. So you've left the topic for a little bit, and then you come back to triangles, and there's usually a good reason. You're building upon formulas and theorems and whatnot. But if you take the time, just a little bit every day after each lesson, to really have your own notebook where you are organizing the information in a way that makes sense to you, your retention, your ownership of that material is going to last longer. You're going to have a better grasp of it. Yeah, a lot of this stuff, do we need it beyond high school or maybe a standardized test? No, but it would be great if we could retain it and not have to learn it from scratch for those tests. So in this case, let's talk about two special right triangles. I used to get these confused all the time in high school. The 45, 45, 90, that's half a square, and the 30, 60, 90, which is half of an equilateral triangle. I would forget in particular which had the root 2 and which had the root 3. This is what I do now. For both of these triangles, I learned them together. The smallest sides are going to be x in the ratios. So in the isosceles, that's going to be the two legs. Smallest side, smallest angle. So I'm going to put an x here and an x here. In a 30, 60, 90, that is going to be the x, and that'll be across from the 30. Smallest side again, smallest angle. Now I have to figure out the hypotenuse for the 45, 45, 90. It is half a square. Half makes me think 2. This is the one that's x root 2. And down below, this is the one with the 30, 60, 90 has a 30 in it. That has a 3. That helps me memorize that this is x root 3. And then finally, I just need to remember 2x. So learning these together, grouping them, understanding that, okay, the smallest is x, and then I build from there. That has helped me store this in my memory. I don't have to look up a trig table anymore. If I'm in a pre-calc class, I don't have to have a unit circle in front of me. Just from organizing the material together, it's helped a tremendous amount. Now, what about for an algebra class? We can do the same thing. I think at the beginning of the year of maybe Algebra 2, one of the things that my students typically want to see the most is factoring. And there's a lot of different ways to factor, and I think I'll probably do a future video where I kind of give you guys a checklist. But as you're learning new techniques throughout the year, you maybe want to have one sheet somewhere where you can go to and say, okay, GCF, maybe I start my factoring by looking for the greatest common factor. And then maybe the next unit was on factoring by grouping, so that's an option. And then patterns, difference between perfect squares or just perfect squares. Have them all in one place. I remember one time in high school, we had done a ton of factoring. We were doing it kind of on the guess and check method. We had trinomials. And then all of a sudden on test day, I had a problem that looked like this. And I completely blanked because there was no constant term. I was thinking about that sort of guess and check method. and I didn't realize I could just pull out the GCF and be done with it. And that's because, once I had done the GCF unit, it kind of went in my head and was gone. And so later on, as a good teacher, she snuck the concept back in, and they'll often do that. If I had been building a sheet like this from the beginning, it would have been fresh in my mind. It would have been on the table for a way to solve a particular problem. All right, so the next skill to really master to become a better math student is to train yourself to spot patterns. I think this is really surprising to a lot of students. I mean, memorizing formulas, yeah, we all know we need to do that. Practice, that's obvious. But what exactly do I mean by this spotting patterns business? So many of my students don't even know how to begin a problem. They will freeze up, and once I just give them a little nudge, all of a sudden it clicks, and they realize, oh, I've done this before, just in another form. And that's what I mean by spotting patterns. It's looking for the familiar and the unfamiliar. So in this example right here, we have what I believe is probably the most important formula in school and probably for standardized tests. It's the difference between perfect squares. So here we have x squared and a squared, and we're finding the difference between them. And right away, we learn that we can break it into two binomials, x minus a times x plus a. So we learn that formula, we say, great, okay, maybe we don't think about it again. And then we get presented with a problem like the one below, 16x squared minus 81y squared. And we're asked to factor it. And maybe this is the first time we've been given a term that has y in it instead of just having x. And we freeze up. We have no idea where to go. But if we look and we kind of abstract, we see that 16 is a perfect square, and so is x squared. And 81 is a perfect square, and so is y squared. So we've learned this difference between perfect squares formula before. Why can't we apply it here? Who cares if we now have a y term? Why can't we just do the same thing? So we're going to rewrite this as 4x minus 9y times 4x plus 9y. And it's that familiar pattern from up above. This is so important on standardized tests. I often tell my students that the math sections on the SAT and ACT, they're really logic tests that happen to use math concepts. They're testing your ability to reason. We used to play a game, I think when we were younger, which one of these is the same, which one is different. It's that same type of skill of seeing that same pattern. What about below? Now we have a term to the fourth power. Maybe we've been going along in Algebra 2 and we've never done anything that wasn't a quadratic, and all of a sudden we're presented with this. And I don't know how to do this. I've never seen this before. Well, we got u to the fourth. Maybe that's just the same as u squared times a u squared. And then we got 25, which is a perfect square, and we got v squared, which is a perfect square. So why can't we just write it like this? U squared minus 5v times u squared plus 5v. And now we've broken it down, and we might even be able to break it down further if we end up with two perfect squares in those parentheses. So seeing these patterns helps us do new problems that we haven't done before, helps us understand, actually, this isn't brand new. This is just something I've done in a different disguise. And for me, that was key. That was the time when I could start understanding, oh, I can get this new material, and I don't necessarily need somebody even teach me it beforehand. All right, so one more quick example of spotting patterns. We learn a lot of rules for exponents, and one of them is this identity. If you have a base and you raise it to the 0 power, it's 1. All right, and then maybe one day we're in class, or again we're taking a standardized test, and we see what looks like a truly horrible equation, something that maybe we've never been asked to do before. 7x squared minus 16 equals 1. And maybe if we've had some exposure to logs, we start thinking about maybe logs are the way to go about this particular problem. But if we see a pattern, if we see this is 7, and it's being raised to some sort of power, we'll call that p, and it gets 1. Well, that's that pattern. That's this pattern above. So that tells me that that power has to be 0. I can now ignore the base and everything else and see that that power, in order to be 0, I would say 0 equals x squared minus 16. And here's the pattern from before. It's the difference between perfect squares. And now we know that we're going to have two solutions for x that will work here. -4 and +4. And it all comes from here. If we're going to have any shot at this problem, we need to see the hidden pattern lying underneath it. This is something that you will develop more when you memorize more formulas and when you practice. All these three skills, these three things that I think are essential for math, they reinforce each other, and the more you do one of them, the better you're going to get at another one. Actually, one more example of patterns, this time from geometry. A good formula, a good special triangle to know for tests. We have the 3, 4, 5, often called the Carpenter's right triangle. Yeah, we can use Pythagorean, but if we're worried about time and we want to finish this section a little quicker, maybe we start to realize, hey, wait a minute, this is actually the 3, and this is the 5, and that means I need a 4 down here, but since every term is being multiplied by 2, I really need an 8. And over here we have a right triangle, and we have an 8 and a 4, and maybe we start realizing, okay, this is our 2x, this is our x, this is a 30, 60, 90. Pythagorean's going to tell me, but I don't even need it, that this is going to be 4√3. And I'm a little bit more efficient. And some of the more complicated formulas, it's easy to make a mistake punching in numbers into the calculator. So if you have sort of an extra check, if you happen to remember these formulas, these patterns, then you're more likely going to not make a careless mistake. All right, and now the final component of being a good math student, practice, practice, practice. And I'm sure all you know that, but we need to make it clear, because just memorizing some formulas, it's not going to help you. You really need to put it into practice, to own the material, to try it out in new situations. It's the only way you're going to kind of progress. So in order to do that, here's some tips to make your practice more effective, more efficient. I always tell my students, walk, don't run into problems. And this is particularly true for standardized tests. We think with that timing element, we need to fly, we need to rush. But that's actually going to kill your time, because you're going to go in with indecision. You're not going to know what you're doing. You'll be running around. You won't have a clue where you need to, how to get from A to B. So slow down. Don't start writing an equation unless you know what the parts are. So in a minute, we're going to walk through this one with a problem, but keep this in mind. Start off slow, then speed up. Second point, focus on the knowns, not the unknowns. I had a spelling mistake in there a second ago. I should have left it in. I'm not perfect. You guys don't have to be either. You don't have to be perfect with math. You can learn from the mistakes. But anyways, what do I mean by that? A good example was the patterns from before. We saw some of those weird problems where we had a base raised to a power set equal to 1, and maybe it looked completely new to us. Instead of freaking out, say, hey, wait a minute, there's something in here that I recognize. So hopefully I'll have an example that'll kind of show you that tip. Tip number 3 kind of feeds into the first two. Confidently experiment. Particularly when you're working on your own, or you're working with a tutor, or you're working in a group. Just try something, all right? Even if it's a mistake, it's going to help you figure out what not to do next, and maybe what will work. So for example, on a standardized test, I don't always begin a new problem the right way, but it's not a wasted effort as long as I quickly realize, hey, this is not going to work. It might help me eliminate some answer choices. Don't ever erase on those tests. I want a record of what I did, that mistake, so if I come back later, some separation might help me figure it out, and I don't want to go down the wrong path again. So try something out. You might be in the middle of doing it and make some kind of inference and realize, oh, wait, that's the real way to do the problem. So don't be afraid to try. And finally, in order to catch mistakes and make sure you've done things right, always end a problem by asking, does this make sense? If you're doing a problem and they're asking, how many cows can you fit in a barn, and you get a decimal, well, I don't think we're supposed to be chopping up the cows. So that's not going to make sense. Or, how many people are in a certain class, and you get a negative number, Unless the class is really bad, I doubt that's going to be correct. So ask yourself, does this make sense? It can help you catch a lot of careless mistakes. All right, so let's try putting this all into practice with a problem that a student recently brought to my attention, something similar to this. It's one of those mixture solution problems. Whether you've seen them or not, though, let's give this a try and see how we can use formulas, use spotting patterns, use organizing, and all the different techniques to maybe help us solve a word problem. So how many liters of a 15% saline solution must be mixed with a 60% saline solution to create 10 liters of a 45% saline solution? So hopefully this is a type of problem you've seen before. If it's new to you, the very first thing I would suggest here is organization. Organization is really going to help us work through this problem. So tables would be great. We're not going to rush to a formula. Let's take the numbers out of the words and get them organized and group them together naturally. So why don't we have a column where we're putting the percentages that we would like, that we have and that we'd like to achieve. And I'm going to write those percentages as decimals. So we're going to have our 15% solution here, our 60% solution right here, and our 45% solution that we're trying to achieve down below. All right, so those are our different percentages. All right, now what else do we know? We know at the end of the day that we would like 10 liters, so we're going to have liters right here, of the 45% solution. But we don't know is how much of the 15 and the 60 we need. What do we do in algebra? What's familiar about this when we don't know something? We declare a variable. We could declare two, but I always, when I do these problems, like to pretend that variables cost money and use as few as I can. I could make my unknown x the amount for the 15. I could make it for the 60. But at the end of the day, the problem is only asking about the 15. So it kind of makes sense to slow down here and say, let's make the 15 the x. Now, how can we represent the 60? Maybe we've learned, maybe there's another problem we've done when we realize if we have two things and they add up to an amount, then we could represent one of those things as the total amount minus the other. So now we have two columns. We have the percentages of the saline solutions. We have the amount of each solutions. And in a mixture problem, one of the things I learned, and it apply to those problems where you're mixing bags with nuts or you're making a fruit punch or something like that, follow the item in the mixture. Let's follow the salt. So for the very first mixture, the 15%, we would figure out how much salt is in there by doing 0.15x. And we would do the same thing with the 60% solution. So I'm going to just multiply those in my head here. We're going to do 0.6 times 10. That's going to be 6. And then 0.6 times x is 0.6x. And then 0.45 times 10 is going to be 4.5. And I always look for a total or something to build in word problems. I usually look for that, I should say. And I would like to build this number here. I know that the total amount of salt in the solution at the end of the day will be equal to the individual parts. So I can write down this equation now. 4.5 equals 0.15x plus 6 minus 0.6x. Let's go ahead and combine some like terms. I should have given myself a little bit more room, but we'll do the best we can here. Negative 1.5, I'm bringing the 6 over, is equal to negative 0.45, and that's 0.15 minus 0.6. So now I just need to divide through by x, and in this case I'm going to get 3, and what ends up being 3 1/3. And that's okay in this instance. Having a third of a liter is fine. It's not going to present any of the issues before. It makes sense. It's less than 10. It's greater than 0. I'm not using every technique I talked about, but I'm starting slow. I'm organizing the information. I'm seeing how this relates to problems I've done before that were some kind of mixture or solution. I'm revisiting concepts about how to find how much of something is in a solution if you know its percentage. I'm invoking all those things to help me get through the problem. All right, so that's all I really wanted to go through today. Nothing groundbreaking here, but I wanted to give you guys sort of a good foundation to begin this school year. I know it's going to be a little bit difficult being in class full time again. Some material from last year may not have been covered. So hopefully these techniques will help you feel not overwhelmed. And remember, if you are having an issue, always seek the help of your teacher, your classmates, tutors, and to sort of practice what I'm preaching here. If I'd like to ask you guys for help, as I've been doing at the end of these videos, if you could like this video, subscribe to help me get the word out. Tell your classmates, leave a comment below, give me some ideas for future videos. Tell me how I can do these better. And if you really like what I'm doing here, supporting the channel on Patreon would be great. I have information in the link below. I have extra practice problems there. I have extra tips for taking tests, explanations for the practice problems. So just a lot of great materials. And I wish you all the best luck this year.